Well, we're here at the Georgetown Power Plant Museum for the annual meeting. Some of the hobbyists are here with their beautiful engines. We have the steam train running and a number of other displays in the power plant. And I'm here meeting with Roy Foote. You're an amateur machinist, and you've built some beautiful, beautiful engines here. I'm a professional machinist. I work for Boeing and Goodyear and Convair and people like that. And frankly, coming from a professional level, looking at these so-called amateurish jobs, I'm blown away. This stuff is so beautiful that I don't think half of us or a tenth of us in the professional world could even begin to come up with anything like this. This is just fantastic. Could you tell us a little bit about the machines you use and just generally how you went into building this?
Okay,
like this is a radial aircraft engine, I take it?
Yeah, 7-cylinder radial, 4-cycle. Yeah, you bent the rock. And so there had to be a place. It's not a model of a full-size one. It's strictly just a project for amateur machinists.
It's just the basic structure without any particular model being intended.
Right. It was made by a guy in England. That's where the drawings came from.
A lot of the models come from England.
Yes.
They're quite model maker people.
Yes, they are.
So we're sort of catching up with that level. But we have a ways to go yet. Well, anyway, tell us some more about that.
Okay, it's got, this tells quite a bit about it. It's 0.75-inch bore, 0.8-inch stroke, 2.47 cubic inches total.
That's all the cylinders.
That's all the cylinders, 40.5 cc's. And the propeller size, I should have brought that, is 20-inch diameter and 8-inch pitch. And then I have a little bit writing down here. This engine contains a total of 669 parts. 481 of these parts were fabricated, including the 6 spur gears, spark plugs, carburetor, and valve springs. 188 were purchased, that's the parts, mostly bolting, 179, and ball bearings, 9. Approximately 1,200 hours to complete this engine. There are no castings on this engine.
Okay, so you worked with just basic bar stock.
That is correct.
And then you just cut off pieces and machined them, doing all the cutting, shaping, everything with your machine tools. So nothing was cast in advance and pre-shaped for you?
No.
All right. Well, so you could make something like this just going down to the metal yard, getting some bars of aluminum or whatever, and pieces of steel or some tubes, and do it. Now you had to buy like the spark plugs.
I made the spark plugs.
Oh, you made the spark plugs. You even did that.
Yes. Same with this engine. This was originally designed and sold as a casting engine. The bottom casting and the top casting and the head. But there again, I don't use castings. This is made from bar stock. And I made all these spark plugs. Oh, I should have taken this off. This is just so you don't get splashed with some of the little droplets coming out of the exhaust when it's running. And it's a water-cooled engine.
Could you tell us a little bit about making spark plugs? I've wondered about that myself. It's
very similar to making anything else except that they are much smaller. And it's hard to say just what the exact sequence is at the moment. But you start with a square hex bar.
Hexagonal bar stock.
Hexagonal bar stock, and I think this is 5/16, 3/8 hex, I think it is. And without a drawing here, it'd be very difficult to really explain what I do first.
Well, you have an insulator in the middle.
Yeah, that's corian, that's the white stuff.
So that's like a plastic? Or is that more like a ceramic, or what is it?
It's more of a ceramic.
Okay.
I believe. It's corian, which is used for counters, and other things of that nature.
Now, can you cut that with high-speed steel, or do you need carbide for that, or?
No, it's not that hard. It cuts very nicely with the same cutters I use for aluminum. It's easy to do.
And you have an electrode going down through the middle,
Yes.
and then you have part of the metal basis there with another piece of metal to make the other part of the spark.
No, that piece at the bottom, you have the threaded part going down, and then at the end there's a piece like that. And then and from the top, the wire goes down and stops about 20 thousandths short of it. But that piece on the bottom is part of the initial piece of metal that I make the spark plugs out of.
Oh, so you leave that metal on there when you're machining, and then bend it over.
No.
You don't even do that.
It's already there. I take the sides off first, and then by that time it exposes the light
I
through
see.
there. And then last of all, I very carefully take off the end from one side. Originally it was like that. Then you end up with that electrode at the bottom.
Oh, I see. So you drill in, but don't go all the way to the bottom, and then you can mill the sides and leave the thing sticking out like that.
Right.
All right.
And of course, the thread goes in just before I do that end piece.
Now, how do you thread those?
With standard dies.
Okay, so you use a twist die to put that thread on there.
Yes. They go in a holder, and the holder's held in the lathe. And like that.
Do you do any single point threading in that, where you'd use the lathe to cut the thread? You do any of that?
I've never used a lathe yet to do any threading. My lathe is not a very expensive one. It's a 9x19 Grizzly lathe, and it's not a precision machine by any means, as you can imagine. And so therefore, rather than even try that, I've just stayed away from it. I just do it all by die.
Well, I've cut a lot of threads with the lathe that moves the tool for you.
Yes.
It's an interesting operation. I showed our friend Orrin how to do that one time on his lathe, and it's quite a skill. But you don't have to be able to do that to build even something this wonderful.
The only time you'd have to do it by hand is if you had a job that needed some extra fine, large threads that there are no dies made before. Then I'd have to get somebody else to do it for me.
Yeah, if you're making a lid or something to screw onto something else, and you have a big diameter and you've got to have very fine threads, there's really no way to get a die onto that. I made some covers for the Coast Guard cutters, helicopter hooks that were like that. These were big brass discs that had a threaded boss on them, so you could screw them on to cover their hooking hole for the helicopter. Those were single pointed, but we didn't have any. Of course, we didn't have any dies that would do that. But anyway, this you did with just the regular dies you could get at the hardware store, or maybe at Kohl's or someplace like that.
Right. Marshall Tool is the place I usually get mine from.
And did you have to swage the metal over the corian to hold the corian tight?
No, up until a certain point, and these are included, I just used Loctite to hold the ceramic in. But later on, I changed my design so that the corian is threaded, and then you have an inboard thread in the hole that the corian screws into, besides the thread on the bottom for going into the engine. And that's my best design on how to build them so far.
So the corian is best threaded into the metal base.
Yeah, but there is a thread inside top of the spark plug to take that. Otherwise, it just pushed in and blew. But now, with the ID inside thread, the outside thread on the corian, which you can't see from here, of course, and then that just screws in with a little Loctite.
Okay, so you tap the inside of the metal base, and then screw in the corian that's threaded to fit it with Loctite, so it fits in mechanically and it's held in with the Loctite grip, which is sort of what, like an epoxy plastic of some kind?
It's along that line. I'm really not up on what those glues really are.
Well, anyway, this is John Rodgers and Roy Foote. We're
Roy Foote, actually.
oh, Roy. I'm sorry, Roy. We're looking at his beautiful engine here, and we've talked a little bit about how he made one of his detail parts that people might wonder how you would do it, but they work and they would actually run the engine. Oh, what a beautiful job! I hope to try one someday. Thank you so much.